In this video, we will be reviewing the tasks for Practice 6, which include composing hypotheses, calculating and comparing confidence intervals, calculating types of error, and estimating and interpreting p-values based on the calculations we make for intervals. I've given you guys a text box below to help kind of give you enough information so that you can make some informed decisions about the calculations you'll be making. The sheet labeled Practice 6 in your Activity 3 data spreadsheet is a space for you to provide your calculations. However, I do want you to write in your work for each of the answers that you provide. So I'll be doing some examples just so you have something to refer to. But for the most part, all of the calculations are going to be open for you to practice without any guidance. So that way you get a pretty good set to work with here. I'm just going to skip over some of the questions that I have laid out to show you what is in the text box. So we have the research question, which is, what is the effect of a 12-week dance intervention on balance outcomes in patients with Huntington's disease? Now, the balance outcomes that we are measuring are the functional reach test, which will be referred to as FRT, and the Berg balance scale, which is going to be referred to as BBS. The functional reach test is measured in centimeters, so the greater the distance a person can reach away from their body, the more stability that they have, or the better balance that they have. For the Berg balance scale, this is a 14 questionnaire that's kind of used, or it's a 14 question objective measure that's going to help assess static balance and fall risk. So if you have a higher score on this test, that indicates a higher level of function or better balance. We've collected 20 patients, 10 males and 10 females. The gender in this particular scenario doesn't impact the effect of the intervention. So sometimes you'll see males and females are equal parts. Sometimes you'll see that they are not equal parts in research. Whether they are equal parts or not is completely dependent on what the goals of the researchers were. So if they wanted to get an equal idea of how gender can impact a particular intervention, or they wanted to split up and say, oh, well, the intervention worked for females but maybe didn't work for males, that in itself is something that should be specified in the research question. But because in our research question there's no mention of an effect of gender, we are not using gender as kind of a categorical label for our participants. So in this scenario, the 12-week intervention is our independent variable, or what we are manipulating, and the balance outcomes are the dependent variable, or what we are measuring. The frequency of the measurements were taken 2 times, one time prior to the intervention, which we're referring to as the baseline measurement, and then also after the 12 weeks were up. The results are listed here. So we have means and standard deviations of all of our subjects collected for both measurement times for both tests. So, given this information, we're going to do an example in calculating a confidence interval for the FRT test. And I'm going to do just the baseline. We'll show the work using word equations just so you can see how that works. And then the rest of the examples you guys can work on your own. So we're going to be using a 90% level of confidence for a two-tailed test, meaning that once we calculate alpha from our level of confidence, alpha will be split into 2 tails, one tail above the mean, one tail below the mean. And when we're working with two-tailed tests, we're just trying to identify a change or a difference. So we're not specifying a direction, right? Two-tailed test is usually identified with a non-directional hypothesis. So this means that when we do the balance intervention, we're not necessarily predicting that people's balance will improve or get worse. We just want to say the intervention will have an effect or it will change the balance outcomes. So keep that in mind as we do these calculations. I'll shift us over to our spreadsheet where we've kind of got all of our calculations set up in a nice table. This mimics the table that I created for you guys in the Module 3 practice problems for confidence intervals. So if you haven't looked at that video, take a peek at it to see if it helps you out if you're not understanding any of the steps I'm doing. When we calculate our confidence intervals, we need to have the mean plus or minus the standard error times the z-score that's associated with our level of confidence. So the only thing that we don't have for that formula so far is our standard error. And we can calculate standard error by looking at the standard deviation divided by the square root of our sample size, which we noted was 20. We then can calculate our confidence interval bounds, the lower bound being equal to the mean minus standard error times our z-score. And then our upper interval will be our mean plus standard error times our z-score. And then we can see that we could expect our true population mean for individuals who have not been exposed to an intervention, so this is essentially our control group, right? Individuals with stage 3 Huntington's disease should be expected to have a true population mean that lands somewhere between 7.12 and 9.76 centimeters. We then can calculate our interval bounds for our 12-week. And I just want to make sure that this box is adjusted appropriately. And then this confidence interval would represent where the true population mean would lie for stage 3 Huntington's disease, or people with stage 3 Huntington's disease who have received a 12-week intervention. So comparing these values will come in when we actually try to estimate what the p-value would be for the effect of this test. For now, let's show our work for the calculation of the interval. So like I said, I'll just do the baseline one. You can use word equations to show your work, or you can handwrite your work and then take a picture or a screenshot and then upload that image file to your Dropbox submission. To get the equations to pop up, you just go to the Insert tab, and then over where it says Symbol, you can click on Equation. If your window is expanded, which mine is kind of taking up half of my screen, the equation or the pi sign should show up. If you just click on the pi sign, it will add this equation box. When you click in the equation box, you will notice that an equation tab is added to your main menu. So let's go ahead and click on that. And this should bring up a toolbar that allows us to edit different elements in our equation. So we can add symbols, we can add various structures, etc. For confidence intervals, I think the easiest way to show your work is to just do all of the work for the interval. Because the only difference between the lower bound and the upper bound is a plus and a minus sign. So ideally we can just say 8.44 plus or minus the standard error, which we calculated as 0.80, times the z-score associated with a 90% level of confidence is equal to, and then we can list our interval that we calculated. And remember, we use the square brackets to indicate that we are including both the lower and the upper coordinates. And then just from personal preferences, I typically like it when you highlight your answer so it kind of stands out from your work. And this would be a completely acceptable format for you to earn full credit for your answers. Part B is just related to the other balance tests, so I'll leave that one for you guys to do on your own. Now we're going to calculate the probability of making a type 1 error for the confidence intervals in part A and B. So again, I'm just doing the functional reach test where we used a 90% level of confidence. So I'll navigate back to my equation tab. And when we're calculating type 1 error, we typically can denote type 1 error as alpha. So I'll just insert an alpha symbol. And that will be equal to 100%. I have a bit of a lag, I'm sorry. 100%, there we go, minus the level of confidence. So if we put this in terms of our example, this would be 100 minus 90, which is equal to 10%, or typically we write alpha as a probability between 0 and 1, so we could also write it as 0.10. And remember, if this is a two-tailed test, alpha is divided by 2. So in each tail, we are allowing a 5% chance of error both above and below the mean. For our null hypotheses, or null and research hypotheses, the main thing that you need to know to create these hypotheses is the independent variable, the dependent variable, and what you are looking for. So we've already identified the 12-week intervention is the independent variable, right? Either they have the intervention or they don't. In this case, we're using the same subjects. It's a within subject design. So we're saying that the baseline value is the control group, and the 12-week benchmark represents having the actual intervention. And then we noted that our balance outcomes, being the functional reach test and the Berg balance scale, were our dependent variables. So I've added a note that you can either generalize your hypotheses to just using the dependent variable as balance outcomes, or you can be more specific to the balance test. In this case, we are saying that the null hypothesis, we're looking to show an effect, so cause and effect, not a relationship. I know some students sometimes will put that they think there's a relationship here, but that's not what we're investigating. So the null hypothesis always argues that there is no effect or no significant effect. Okay, so you can start it by saying there is no significant effect of the 12-week dance intervention, which is our independent variable, on FRT, or you can put balance outcomes. Actually, I'll put on the FRT test. Okay. And this should have been intervention. Don't know what happened there. Okay, so this would be the more specific version of the null hypothesis. This would be the generalized one. Both of them are correct. Okay. The alternate or the research hypothesis is going to be mutually exclusive and just the opposite of the null hypothesis. So in this one, we would say there is a significant effect of the 12-week dance intervention on the FRT test / we could also say balance outcomes. Okay, and this, I'm going to move down just a little so we can see these in their glory. There are other ways that you could phrase these hypotheses. I think that this is the easiest way to phrase them, but if you wanted to say, for the null hypothesis, there's no significant difference between baseline and 12-week assessments or baseline and 12-week outcomes for the FRT test, you could also phrase it that way. When we get into different statistical tests that we can use for various research scenarios throughout the semester, you'll see different ways to phrase stuff, so I'm kind of trying to keep it as simple as possible right now, and you're saying there is a significant effect or there's no significant effect. The other thing that I want to point out is that, again, this is a two-tailed test, so we're only interested if there is a change. We're not interested to say that, you know, the 12-week intervention will lead to a significant improvement in balance outcomes. We don't identify a direction. Okay, so there is a change or there's no change. Moving on to part E. Given the results that we kind of have calculated with our confidence intervals, we're going to write the estimated p-value and the interpretation of that p-value. For part E, we're specifically looking at the FRT test. For part F, it'll be for the BBS test. So, we had noted that, I'm just going to type these in really quick, that our baseline interval was 7.12 to 9.76. Got all messed up there. And the 12-week interval was 11.65 to 13.13. Okay. So when we evaluate confidence intervals in comparison to one another, our baseline group is like our control group, right? It tells us where should the true mean of this particular target population be without any intervention. And then our 12-week group is our experimental group. So this would tell us where the true mean of the population would be, considering that an intervention has been applied. We can look at these intervals and say, does the mean of each group land within the same interval? If there is no overlap between the intervals, we can argue that the dance intervention significantly changed the balance outcomes. In this case, balance was significantly changed in terms of the functional reach test. If there is overlap between the intervals, then we can safely assume that each kind of population mean that we're estimating with this interval has come from the same population, in which case we would say the baseline or the control group is not significantly different from the 12-week dance intervention group. So in other words, the intervention didn't improve or make balance worse. So with this, we can estimate our p-value based on the level, the alpha level that we calculated. Right? So P is always going to be less than, greater than, or equal to. Those are kind of your three options. More often than not, we say less than or greater than. Okay? And we know that our level of confidence was 90. We said that our alpha level was 0.10. So given that there is no degree of overlap in here, we are saying that the 12-week intervention significantly changed our balance outcome. Therefore, if we're saying that we significantly changed, right, if we go back up and look at our hypotheses, we are siding with the alternate hypothesis in that there was a significant effect. Therefore, if we accept this, we're rejecting the null hypothesis, which is the one that actually gets statistically tested. Right? So if we reject the null, we had mentioned in class that P is usually less than the alpha level we have set. Okay, sorry for the delay on my screen. So P will be less than 0.10. And the interpretation of this p-value is telling us that we'll write it a different way so that you guys have a different example. The 12-week dance intervention significantly changed. And again, you can either generalize it to balance outcomes, or we can say FRT test results. Okay. The way you phrase it is entirely up to you, but as long as you're getting this idea that there was a significant effect, then you've done your job. Okay. So again, you guys can do the examples for the BBS test. Hopefully this was a thorough enough example of how to create hypotheses, calculate error, calculate your confidence intervals, and then how you can find an estimated p-value based on the comparison of those confidence intervals.